Good morning or afternoon, everybody. Today, our group will be presenting about Chapter 5, DC Linear Machine of the LE260 course at Thammasat University, year 2012. Well, let's begin with some introduction while the two of them are writing the most important equations and the figures that we will always be referring to in this chapter at the moment. On the left there is Chusen. He's writing the equations. Hello, Chusen.
Hello.
And Atik is drawing the figure. Hello, Atik.
Hello.
Okay. So while they're drawing what they have to do, I'll just say some important things about why we actually have to study this chapter. In this course as a whole, we study devices that convert electrical energy into mechanical energy and vice versa. The reason we have to begin with the study of DC linear machine is because it is the simplest version of DC machine which operates under the same principle and has the same behavior as real generators and motors. Hopefully, if we understand the basics that we are going to be talking about today, the details in the later chapters will be easier for us to understand. The conditions that we will study or we will be presenting, there are three of them. Firstly, under no load condition, which will be presented later by Chusen. When machine acts as a motor, which will be presented by me, and as a generator, which will be presented by Atik. Okay, so thank you, you guys. I will take it on from here. Thank you, thank you. Thank you.
Okay.
Thank you. Okay. Firstly, I want you guys to look at this figure. This figure is a figure of a magnetic railway. You will always be referring to this figure throughout the three conditions. Over here, we can see that the battery is connected in series with the switch, and connected again in series with the resistor R, and the current will be flowing in this direction initially. There will be voltage induced as the conducting bar moves to the right in the magnetic field. This will be the conducting bar. Can you see it, Atik?
No.
No? Sorry.
Mode.
Conducting bar. And here we will have a magnetic field directing into the page. So the conducting bar will be lying onto these two metal rails.
Okay.
The rails. Okay, so that's it. This will be the figure that we will always be referring to. And the four most important equations that Chusen wrote earlier are these four. Firstly is the equation of what is it, Chusen? What is this equation?
Force on a wire in
Force on the
a
wire.
magnetic field.
Force on the conducting wire, the same thing, right?
Yes.
Okay. And secondly is the, I'll take this one, is the voltage induced, as I said earlier, as the metal bar, as the conducting bar, moves through the magnetic field with velocity v. Thirdly, we obtain this from KVL, Kirchhoff voltage law. So we go through this loop. So we get minus VB plus IR plus E induced equals 0. So VB equal E induced plus IR. Okay, so that means is F net equal MA. How do we obtain this Atik?
That's Newton's law.
Okay, thank you. Okay, so this will be the general understanding that we have to understand. And Chusen will be starting with the first part. In order to understand how the DC linear machine works as a motor and as a generator, we first of all need to understand how it works under no load condition. In under no load condition, that's the same as saying in how we start a DC linear machine. Okay, so Chusen, up to you now.